Hey guys, welcome back. Today we're going to be talking about systems of equations again, but this time it's not going to be the equations laid out for you. So we're going to be looking at word problems there, and with those word problems, we're going to generate two equations and then use what we know about systems of equations to determine what the solutions are going to be. So just an extra step forward now, but nothing too crazy that we can't handle. We're just going to do a few examples here, and then I'm going to assign a couple other ones that I want you to try out. Don't stress over it, though, and as always, if you have questions while we're going over it or while you're working on it on your own, make sure that you're asking me. So our first one here, the sum of two numbers is 361. We want to be able to write an equation that says that. So the sum of two numbers means that we're adding two numbers. I'm going to use two different variables for that, and what we've been doing in the past is x and y, so I'll keep it as x and y. And so the sum of those two numbers is 361, and the word is means equals. The difference between two numbers is 173. So difference, 173. And if we're talking about difference, it means that we're subtracting. So if we're looking at those two equations there, we should see very clearly that we do have a system of equations and that the y's will cancel out pretty quickly. So if we treat this as an addition problem, our y's will cancel. We'll have 2x here equal to 4, 6 plus 7 is 13, and 3, 4, 5. Okay, so we get that 2x equals 534. And then from there, our last step is going to be to divide each side by 2. That'll tell us that x is equal to, let me take my calculator out just to save some time here. We have 534 divided by 2 is 267. So we're not done with the problem yet, but we did find what the first number is. All that we have to do now is take that value and substitute into either one of the equations that we have here. I'll just substitute it into the first one. So we have 267 instead of x plus y equals 361. And so to solve for y, we're just going to subtract 267. And we'll have y equals 361 minus 267. 94. So there's our two answers. If we were going to write it as a coordinate, it would be 267, 94. And we can write it that way as well. So like I said, the key here is being able to come up with the equation for, or equations rather, for each word problem. And so that's what the goal really is going to be. Then solving the system is another set, but nothing too crazy that we can't handle here. For the second one, there are 356 8th grade students at Euclid's Middle School. 34 more than 4 times the number of girls is equal to half the number of boys. 34 more than 4 times the number of girls. So let's start with that. 34 more than 4 times the number of girls. I'm going to use G for girls this time. Is equal to half the number of boys. Equals 1/2 B. So that's our first equation there. Not really as nice as the previous one, so we might have to do a little bit of work there. How many boys are in 8th grade at Euclid's Middle School, and how many girls? So you'll notice we only have one equation right now, but we actually could have written another equation from the second part that we had there. There are 356 8th grade students, which means that our boys plus our girls has to equal 356. So boys plus girls equals 356. So this is where things get a little bit challenging. We have to kind of figure out what we can do to solve our system of equations here. And neither of these equations are in the same form right now. One thing that you might want to think about doing is getting this so that b is its own variable. Because if we get b by itself, we can then take this whole thing and substitute it into our equation down there. So what can we multiply 1/2 by so that b is by itself? Hopefully you're answering that we can multiply all of this by 2. If we multiply by 2, we're going to get 68 plus 2 times 4g is 8g equals b. Now that we know that b is the same thing as all of this right here, we can take that and substitute it in for our value of b right here. In other words, we can say 68 plus 8g plus g equals 356. So this is an equation where we're obviously solving for girls. Once we know the number of girls, we can then find the number of boys. But what we're going to do is we're going to combine like terms here. We'll have 9g and then we're going to have to do 2 steps to solving this. So our first step is going to be subtracting 68. That'll give us that 9g is equal to 288. And then we're going to divide both sides by 9 to find that g is equal to 32. So 32, when we have this here, we know that the number of girls is 32, so now we have to find the number of boys. Now, you can do either one of these equations, but I personally think the second equation is quite a bit easier there. So if we use the second equation, we have our boys plus the 32 girls is equal to 356. Obviously, it looks like there's a lot more boys in the school than there are girls. We're going to subtract 32. And we're going to find that our boys are equal to 356 minus 32, which is 324. So for our school, there are 324 boys and 32 girls. 3, 2, 4, 32. And we can even test that out in the first equation there. Half of 324 is going to give us 162. And if we take 4 times 32, we're going to get 128. 128 plus 34 will also get us to that 162 there. So another way that we can kind of test that out to make sure that it works. So wanted to do one more example with you guys today, and this one's actually very similar to our troll problem from Khan Academy last week. A family member, now instead of a troll, it's your family member. I mean, depending on how you think of your family members, that could be the same person, you never know. A family member has some $5 bills and $1 bills in their wallet. Altogether, she has 18 bills and a total of $62. How much of each bill does she have? So altogether, she has 18 bills. We know there's $5 and $1 bills. So I'm going to make my 2 variables, F for $5 bills, and O, even though O's look a lot like zeros, we're going to use O for this for $1 bills. So we know that the $5 bills and the $1 bills together, they have 18 bills altogether. So our F plus O is going to equal 18. She has a total of $62. So what we want to do for that second equation is we know that there are $5 for every $5 bill, and there's $1 for every $1 bill. And so we know that the total here is going to be $62. So what we can do is we could either multiply the top one or the bottom one by -1. I'm going to multiply the top by -1 just because I think it'll make things a little bit easier. So when we do that, I'm just going to rewrite it below this. We'll have -f minus 0 equals -18. So really what we're doing is we're subtracting these two. And I said -0 there. I meant to say minus O because our O's cancel out. And we'll have 4f equals 62 minus 18, which is 44. Well, that tells us that the number of $5 bills is 11. So if there's 11 $5 bills, how many $1 bills are there? Well, we know that if F is 11, then O has to equal 7 because 11 plus 7 is 18. So for our $1 bills, there's 7. We can even test that out here. 11 times 5 is 55. 55 plus 7 does get us to 62 there. So the only thing that's different about what we're doing now and what we were doing before is we're coming up with the equations instead of them just giving us the equations. What I'd like you guys to do is really take a look at some of the exercises here. So exercises 1, 2, and 3. And then it does get into the problem set, but if you want to do the problem set for extra practice, you can. I'm really just looking for exercises 1, 2, and 3 for a little bit of extra practice. Try your best on this, and as always, if you have questions, make sure that you're asking me. Good luck on this, and have some fun with it too. Next.